technician. I was a law student, and I was the engineer and technician to Jim Quintieri, who was last year's keynote speaker. And I first taught fire safety codes and standards in 1975. So I've been doing this for 36 years. This particular paper, my colleague, Professor Miller Hooks, and Mr. Fang, he's her graduate student in the Department of Civil Engineering, and they are transportation modeling types. They build the models. I don't do it, so you won't see the equations because they're not here. Now, the fundamental of evacuation was safe area behind a defensive perimeter. Now, in buildings, we get very used to the idea that the exits are a safe place to evacuate to, that once people are there, they're safe. But that is merely a construct of the way buildings are built. It's not inherent in evacuations, as the King's Cross subway system shows. Now, we use models for code compliance, disaster planning, and real-time emergency operations increasingly. As we try to evacuate cities, they use the models dynamically in the actual evacuation process. What am I doing right there? For my purposes, here's the critical thing. When Captain Smith ordered the evacuation of the Titanic, the very first thing the officers did is they went to the arms locker and they got their pistols. Okay? They had legal authority and they had guns. Anybody who says you can run an evacuation without command and control has a huge burden of proof. Okay? They needed guns to make it work. And the willingness to use them. Now, ship and aircraft evacuations are routinely designed to be controlled in some form. Those are controlled evacuations. But most building and fire safety evacuation plans are uncontrolled and rely on autonomous, predictable human reactions after the initial detection of the fire. Whether those autonomous reactions are actually predictable or not is highly debatable. Now, to really understand controlled versus uncontrolled evacuation, go to the bathroom in your house. Okay? Every household with indoor plumbing has controlled and uncontrolled flow. All of the input water systems into a house are controlled. They all have valves. But sewer systems have no valves. They are uncontrolled systems. None of the drain waste and vent pipes downstream of the toilet have valves. Civil engineers deal with this all the time. That's where they start. All right. So sanitary engineers talk about the available sanitary flushing capacity as long as it's greater than the required sanitary flushing capacity. It's exactly the same. That's why it's hydraulic flow. All fire exiting systems that use the ASET, they're all designed around sewers. The Romans invented this concept. Okay? Uncontrolled flow. Now, but how do you assure that you've got enough capacity? Most fire and similar phased evacuation plans are effectively similar to these uncontrolled sewer systems, and they have no command and control systems. As a result, they rely on over-design, assumptions, hope, and guesswork. Those are the engineering tools. There's hope, there's guesswork, there's over-design, and then, that's what engineers do. But can we control how many toilets will be flushed at once? See, builders, they want to put just very small pipes in the building, so they want to implement phased flushing, okay, where only some people get to flush at once in order to have smaller pipes. It's exactly, everybody just wants smaller drains, so they want phased flushing. So, for example, that you weren't supposed to flush the station. This is a famous diagram of flushing during water consumption during the Super Bowl. During the Super Bowl, you get these spikes. Well, actually, the flushing one is much bigger than the water one because the way the toilet's flushed. So they overwhelm the pipes in some buildings during the Super Bowl. It's kind of interesting. So how does a regulator analyze the acceptability of phased flushing? What controls are needed? Well, to get a few concepts right up front, we always use the term authority having jurisdiction, and this is the entity with legal authority over the evacuation. This is a non-trivial issue, as Charlie Fleischman was pointing out. To know who's in charge of the evacuation of a structure is the single most important thing engineers have to learn. in charge and why, and what gives them the power and what gives them the command and control. Now, command is a statement by the authority having jurisdiction, people with legal authority, which is required to be followed by persons or organizations involved in the evacuation. And control is the legal and practical system for implementing and enforcing the commands of the authority having jurisdiction. So the law of the sea gives the captain the legal authority, and the pistol is the control system. Now, I'm sorry, I thought there are slides here on work. Okay. No. This is our case study, which we're going to describe. We're describing a town which we're going to evacuate, Smithtown, a town in western United States, 20,000 people, hypothetical town, one major highway with 2 roads out of it, which is fairly typical, and they're using counterflow, which is you're using all the lanes to evacuate the town. So, in other words, you're using the main highway, you're running everybody out of the town, using all the lanes, using counterflow. When the fire jumps the containment and cuts off one of the roads by destroying the bridge. Now, there's a small logging road here that you can use, but it's not going to take all the cars that were sent down that way. This is a variation on the Mont Blanc tunnel fire problem and on the King's Cross station fire, has elements of both. So, as the fire jumps to the pre-fire evacuation plan, you send half the residents, and you have to be able to use this logging road. Well, if you're going to convert people from driving down a highway to going on a logging road, you need command and control. Okay? So here's your alternative exit. Your logging road is an unimproved road. It's 2 kilometers. It's a possible escape route, but will only accommodate individual cars and 4-wheel drive vehicles. And the logging road's capacity is much lower than a single lane of the highway. So now you have to have the ability to restructure your evacuation dynamically in real time. How do you model this? It's absolutely no different from the decision on the Titanic, where they put women and children first in lifeboats. That takes real-time changing. Here are the command and control activities in this particular case. You have to halt a further flow into the dead end of the highway. You have to remove people from vehicles, direct them on foot to the escape route, because turnaround is impossible. You have to compel people in the dead end to leave all the property behind. When, even Dave didn't mention, in the transport facilities, people carry luggage. And they tell you on airplanes, leave it behind. But nobody tells them at train stations to leave your luggage behind, and luggage piles up in the exitway. Nobody who models exiting from transport facilities considers the luggage. They just wish it away. Oh, that's complicated. Ooh, we can't do that. I asked the folks from a major consultancy, what do you do with the luggage? They say, we assume it's not there. Well, that's a command assumption. All right, they compel you have to leave the property, you have to prevent trailers, RVs, and similar vehicles from using and blocking the exit road. So you have to tell some vehicles they can't go, and you have to figure out what to do with them. So you have to move people on foot. Only reliable cars and 4-wheel vehicles. You have to divert the vehicles and move property to make room for walkers, because you've got 2 things now. You've got people on foot, and you need to put them into the vehicles. I've done this in real fire. It gets exciting. All right, you have to place the walkers in vehicles. You have to halt for the movement from the town. You have to deal with citizens whose vehicles, and in the United States, of course, these citizens have guns. So that's the command and control problem that you want to put into your model. This makes most models, look like kicker toys. Now, performance-based designs routinely incorporate unstated assumptions about evacuations directly into the engineering, so realistic modeling requires proper incorporation of these command and control capabilities. So, we're going to look specifically at the things that you have to be able to incorporate into models in a meaningful way in order to actually model real evacuations rather than the fantasy land evacuations that are used in most designs. First, you have a prepare function. In other words, all of these were designed collaboratively with my engineering colleagues to be mathematically implementable. That is, these are terms which you could describe mathematically. The prepare function requires people to take action conducive to the evacuation. For example, leaving your vehicles and possessions behind. You're told on an airplane, leave your carry-on luggage behind. You have to prepare people